All right, ladies and gentlemen, boys and girls, let's solve another differential equation. This is going to be another ordinary differential equation, and it's going to be separable. So let's go ahead and get started. So right now, to put it in a better form, we're going to go ahead and change this y prime to dy dx. It's going to put it in Leibniz form. So we're going to get dy dx plus y squared sine of x is equal to 0. This looks a little bit intimidating. We have a trigonometric function here. It's multiplied by a square. Is this gonna be difficult? Who knows? Well, let's go ahead and tackle it. I'm gonna show you it's not gonna be too difficult. So we have dy dx plus y squared sine of x is equal to 0. What we could do is go ahead and move this y squared sine of x term to the right side. So we're gonna have dy dx is equal to negative y squared sine of x. Okay, so now all we really want to do here is, well, we want to separate. We want to get the y's on one side and the x's on the other side, and then we'll go ahead and do our handy dandy integration. So how are we going to do that? Well, we can multiply both sides by dx, and we can divide both sides by negative y squared. Or do we want to divide by, yeah, negative y squared, sorry. So we're going to go ahead and get dy over, actually, we'll just divide by y squared, not negative y squared. Dy over y squared is equal to negative sine of x dx. All right. So now I think we're in good shape to do some integration here. So let's integrate both sides. We're going to get integrate dy over y squared is equal to the integral of negative sine of x dx. So what are we going to get here? Well, the integral of 1 over y squared the integral of dy over y squared is just going to be negative 1 over y. Now, why is that? Maybe I can go ahead and be a little bit more explicit here. So let's write this out in a better fashion. Let's write it out as y to the negative 2 dy. So how do we integrate this? Well, we use the same rules of integration we always use. We're gonna increment we're gonna use the power rule for integration. We're gonna increment this negative 2 to negative 1, and we're going to divide this all by negative 1. So what does this become? This becomes negative 1 over y plus c. We're going to have our constant of integration. It's going to equal to the integral of negative sine of x dx. And what is that? Well, the integral of sine x is negative cosine x. The integral of negative sine x is just good old cosine x. So we're going to cosine of x plus c. All right, we're getting there. We're almost done. So we can go ahead and kind of combine the constants. These are just constant values, so we don't really need to keep track of them. We can just combine them. So negative 1 over y is equal to, let's get them all the constants on this right side, cos of x plus c. And now we can basically solve for y of x right here. So we can go ahead and get y of x. How are we going to do this? Well, we can multiply each side by y, and we can divide each side by cos of x plus c. So in the end, we're going to end up with y of x is equal to negative 1 over cos of x plus c. And if you prefer to write this in a better form, get rid of the negative 1 on top, you can write this as y of x is equal to 1 over c minus cos of x. And voila, here we are. This is the solution to the differential equation y prime plus y squared sine of x equal to 0. So what does that mean? This value of y solves the equation. You can go ahead and plug this into this equation and you can verify that it's correct.